Hello everybody, this is me, Yusuf Saleh, again, chemistry teacher. Today we're going to study, in this mini lecture, we're going to study the revision of section 3.2. Let's read the questions, and always I'm recommending you read the question at least 3 times, even if the question is what is your name, okay? Because sometimes one word can make your answer wrong. Okay, so please read any question, read it 3 times at least. Okay, let's start with question 1. Question 1, define each of the following terms. Atom. What is atom? Atom, of course, the definition of atom changed historically, but the best definition for atom, it is the smallest particle of an element that retains, that keeps the identity and the properties of the element, which means atom of one element and another atom of another element, they represent 2 particles of 2 different elements with different properties, different identities. Second, electron. What is electron? In last mini lecture we studied electron. Electron is a particle, a subatomic particle, negatively charged, low density, and located outside the nucleus. Located outside the nucleus. Let's repeat. Electron is a subatomic particle, negatively charged, low dense, and located outside the nucleus. This is the term B. The third, the nucleus. What is nucleus? Nucleus is a very small region in the center of the atom, very small region, very narrow region, where the positive charge and most of the mass concentrated. So you have a, let's draw here, okay, for the, sorry, okay. Okay, suppose that this is the atom, the nucleus is here, and the electrons are around. The electrons are on the positive part, and very high dense part is in the center, and the electrons, negative electrons, are outside. Okay, what about the protons? Protons are located here inside the nucleus. What is proton? Proton, subatomic particle. Proton, subatomic particle, positively charged, high dense, and located inside the nucleus. Let's repeat. Protons are subatomic particles, positively charged, located inside the nucleus. Okay, and finally we have a neutron. Neutron definition is similar to proton, but instead of saying positively charged, we will say non-charged, which means neutral. So neutrons are subatomic particles, non-charged, which means neutral, very high density, and located inside the nucleus. Also, you see that the only difference between proton and neutron: protons are positively charged and neutrons are non-charged. Okay, let's move to question 2. Describe the conclusion made by each of the following scientists that led to development of current atomic theory. Of course, current atomic theory is not made by only one person. Current atomic theory made by additions of many scientists on a very long duration of time, very long time. So let's see Thomson. What did Thomson say? Thomson discovered what? Electron. Thomson discovered electron. Okay. But he did not call it electron. He said what? He said cathode, but later called electron. Millikan supported Thomson. He found a ratio of mass of electron to its charge. And he found that the ratio of mass to charge is very, very low. Ratio, of course, this is for electron, of electron. This is Millikan. Okay, Rutherford. What did he discover? Rutherford discovered nucleus. What did he discover? He discovered nucleus. And he said nucleus is a positive, dense, very narrow part in the center of the atom, and most of the mass and the positive charge located there. Let's move forward and see question 3. Question 3, compare these subatomic particles in terms of location in the atom, mass, and relative charge. I prefer having a table for this issue. Okay, let's draw a table here. And in the table, we're going to write the name of the particle, the location, the charge, and the mass. Okay, suppose that we have, this is the table. Okay, this table is some rows and some columns. So we have 3 types of particles. And so first one, let's say which one? Proton. Okay. Proton. Just a minute. Let's do something, change here. First, let's say we have particle, okay. Now, this is the particle's name. Particle, okay, location. Charge. And mass. Of course, mass is relatively. Okay, now let's the first one. Here, the first one is a proton. The first one is proton, sorry. Okay, first one is a proton. Proton, what is the location of the proton? The location of the proton is inside nucleus. Nucleus, okay. What about its charge? Its charge is positive. Its charge is positive. What about the relative mass? But of course, the mass is very, very low, but the relative mass relative to the total mass of the atom, the total mass of the protons compared to total mass of the atom is high. This is the first particle. Second particle is a neutron. Okay, neutron. Also inside the nucleus. It is just like the location of the proton. This is inside the nucleus. What about the charge? The charge, neutrons are not charged. Neutrons, which means they have 0 charge. Neutrons have 0 charge. Okay. What about the mass? Of course, we say that most of the mass is inside the nucleus. Inside the nucleus, there are protons and neutrons. So the mass of neutron is also high. Okay, now let's go forward and with the final subatomic particle, which is electron. Okay, electron is outside. Outside what? Outside nucleus. Okay, what about the charge? Electron outside the nucleus and have negative charge. So the charge is negative. What about the mass? It is only 1 out of 1,837 part of the total mass of the atom. So it is low. Mass of electron, we can say it is very low. Okay, it's about question 4. Let's see question 4. Sorry, it was question 3. So this is the solution of question 3. Let's move to question 4. Why is the cathode tube in figure 4, the figure 4 is connected to vacuum pump? Okay, vacuum pump. Thomson used a vacuum pump in order to empathize the gas inside the tube partially to make it lower density, to make it lower pressure. Why lower pressure? Because gas under low pressure conducts electric current better. Let me repeat. He used a vacuum here, a vacuum pump, in order to empathize the gas inside the tube partially to get it lower density and lower pressure to enhance, to improve the electric conductivity, because gases, all gases under low pressure conduct electric current better. So here to lower, sorry, okay, now to lower the gas density. Of course, when gas density lowers, also pressure gets also lower. Gas pressure first. And what? And make its conductivity. Conductivity to what? To heat? No, of course not. It is conductivity. Conductivity to what? Conductivity to electric current. To its conductivity to electric current better. Why? Because gas under low pressure conducts electric current better. Okay, let's move to question 5 and read question 5. Okay, evaluating ideas. Nucleus forces are said to hold protons and neutrons together. What is it about the composition of a nucleus that requires the concept of nuclear forces? Inside the nucleus, the particles are very, very close. So instead of repulsion between alike particles, they attract each other. Who justified this? The the physics scientist Newton, Isaac Newton. Isaac Newton said when the particles are very close to each other, they attract each other more. So the nucleus is staying firm, staying united, not smashing. Why? Because the particles are very, very small, very, very close to each other, and they attract each other instead of repelling each other. This is all about today's my lecture. It's short because it was only section review. I should get benefit from it and have a nice day.